Welcome to Mitrex, where nature's brilliance fuels our vision. We transform buildings into vibrant energy creators, weaving solar technology into every sunlit surface. Our cutting-edge materials turn facades into micro-power plants, blending efficiency with aesthetics. As the world's largest building-integrated photovoltaic manufacturer, our Ontario plant crafts over 25,000 square feet of sustainable materials daily. From design to installation, Mitrex powers a brighter, greener tomorrow. Join us in shaping the future.
Good afternoon, everyone. My name is Danial Hadizadeh. I'm the founder and CEO of Mitrex. It's an absolute honor to be here for the grand opening of the Sunrise, a building that's covered with BIPV and cladded with Building-Integrated Photovoltaic. This is a grand opening for Avenue Living and the building and we just found out about the Guinness World Record for the world's largest BIPV mural, 85 feet tall on the north elevation of this building. At Mitrex, our mission has always been to push the boundaries of sustainability. And here we have a prime example. What is possible to achieve in a sustainable building? The Sunrise is a shining example of that vision coming to life. We are proud to be partnered with Avenue Living. Their bold vision to create this building and design, retrofit, and bring back to life a building that was not a significant point here and now become a focal point. This 85-foot tall building integrated mural is the world's largest, and it's not just art. This is actually a powerhouse. This wall is generating electricity day in and day out. Every single day of the year, as the sun shines, the building is acting as a power plant. There are over 2,000 panels on this building, and they're all generating electricity. Every single piece of this building is generating electricity. Almost 60%, this 2,000 panel, they will result in almost 60% reduction in the greenhouse gas emission, and it's equivalent of taking about dozens of cars off the road. What makes this project special is the collaboration behind it. Working with Avenue Living, Bank of Montreal, Chandos, and the local community, we have shown how innovation can transform a 1970s building into a sustainable and cultural pride. The Sunrise isn't just a building, it's a model of future urban living, where energy efficiency, affordability, and community, they all come together. As we celebrate the milestone, I want to thank everyone, Avenue Living, Lance, the artists behind it, as well as the entire team. I'm gonna pass the mic to Neil here from Avenue Living, and Neil can tell us more about his experience on this project, the goals of the project, and how we got here.
Sure.
Thank you, Neil.
Thanks, Daniel. Thanks for having us. Thanks for joining for our grand opening. So my name's Neil Shannon. I'm our Executive Vice President of Capital Projects. I've been involved with Daniel, the Mitrex team, and the Chandos team from the start of the project. Originally, when we wanted to introduce solar production to the building, we didn't know Mitrex existed. So our original plan was to put some traditional solar panel on the south face only of the building. Why we stopped there is we didn't like the aesthetic of what that would produce. So we started exploring ideas of how to bring more solar and a better looking product to the Sunrise property. And that's where we discovered Mitrex and the Toronto-based manufacturing plant that produced our panel on this product. In terms of our experience, it's been great. It's been collaborative. We've worked close with the Mitrex team on design assist and with Michael from the installation team to pull off the project, and it's been fun. It's been great. We're looking forward to another project in Calgary with Mitrex hopefully here, and Yeah, it's been a pleasure. I'm glad we're at the finish line. We're getting the last connections wired in. We're looking forward to the building producing power. The Mitrex panel is part of a larger list of measures for the building. Our goal is to reduce our greenhouse gas consumption by about 60%, and the solar generation and also the added insulation of the wall assembly are two big contributors to the greenhouse gas reduction goals. So yeah, thrilled we were able to completely change the envelope of this building. We've made it airtight, watertight, and yeah, thrilled that it produces power. So yeah, to close, thank you for your team and everyone's involvement from Mitrex. It's been a great process, highly collaborative again, and we felt really good solving problems together and making it happen. So yeah, thank you.
Neil. Thanks for your bold vision and executing on it.
Absolutely, yeah.
Any challenges you had with the financing or from banks or any financial institution about utilizing BIPV or in general as a solar product?
Sure. Yeah, we didn't have any challenges. So to start off our journey, we would complete an energy audit of the building, and as long as our intended upgrades are listed as energy efficiency or energy conservation measures in that audit, then we can include it when we go out to our financing partners. So for this project in particular, we worked with the Bank of Montreal, and they were excellent in supporting us with the work we wanted to do here. So we had no troubles at all. It was, even though it was new for us, new technology for us, they were very supportive in letting us break trail and try it out and try something new.
That's great.
Yeah.
Thank you.
Yeah,
If you have any other comments, let us know. Otherwise, Corey, we can get closer to the building so everyone can see the material up close. And then we're gonna pass the mic to Dustin here from Chandos, our construction partner. There we go.
Appreciate it, Daniel. Yeah, thank you. My name is Dustin Tonsi. I'm a project manager for Chandos Construction, working on behalf of Avenue Living. We work to facilitate the complete deep energy retrofit of the Sunrise project. It's been quite a journey. Started here late 2023. We've worked hand in hand with Mitrex. Like Neil said, high level of collaboration. We've been meeting weekly, meetings on meetings on meetings, really just getting into the nitty gritty, working through the details of design, how we're going to facilitate mounting the panels to the building, to all the finer envelope details as well. I just want to say it's been an absolute pleasure working with the Mitrex team and Avenue Living. Really excited that we're getting here to the final stages. It's been quite the journey, and really looking forward to the finished product here.
Thank you, Dustin.
Yeah, thank you.
I'm gonna put it on Corey now, and let's get closer to the building, Corey.
Sure. I mean, as everybody's mentioned, this is obviously a very exciting project for Mitrex, for Avenue Living, and for the construction industry in general. You know, the ability to take an old building like this that, quite frankly, was in need of repair and in need of retrofitting and a facelift, and to be able to give it a look like this with the world's largest building integrated mural on the side, but also to have this building generating roughly 60% of its own electricity from its building facades is just phenomenal. And like Neil said from Avenue Living, the combination of, you know, retrofitting this facade, adding the new air and water barrier, adding new insulation, actually improving the overall building envelope performance, as well as compounding that with generating on-site electricity, is just absolutely massive. It's fantastic for this building. It's fantastic for construction, for the community. This is in a part of Edmonton that is, you know, redeveloping, cleaning itself up. It's close to the Rogers Arena, where the Edmonton Oilers are actually about to play Game 4 of the Stanley Cup Finals in a couple hours here. So Overall, this is very exciting for everyone involved, not the least of which us here at Mitrex. We're very, very proud to be on this building and to be in this part of Edmonton. And we're very, very proud of the finished product here. So yeah, thanks, Daniel.
That's great. Thank you, Corey. So these projects, it won't happen unless the ideas, the engineers, and everyone designing it can execute and make it real. And that is when Michael comes into play. Michael is the one who's making it happen, making it real. Till then, you're talking about drawings and design, and then Michael comes and tell us about your experience, Michael, about the process of dealing with BIPV, installing these retrofit, deep retrofit, and the whole process.
Thanks, Daniel. The process, I could truthfully say that the process was a good process. It was a pleasure working with Avenue Living and the Chandos team. A lot of the general site issues that you would have on a construction site, they were handled, and so it allowed us the opportunity to deal with the other portions of it, the things that are non-traditional, the integration of solar and how that would all work on a retrofit. At the end of the day, it is a retrofit, and that comes with its challenges. We were able to surpass those challenges or be able to overcome those and then get to this point. One of the good things about these panels too is that any panel can be serviced if necessary. We don't have to come and tear down the whole wall. Each individual panel, if it gets damaged or if something like that happens where we have some kind of cell failure or something like that, we can go and take that out individually and not have to dismantle the whole thing. So that's a good thing. Anytime that we are a part, or I'm a part of a project that is able to build up the community, that is able to take an older building and improve it and add some sustainable energy, it's always a good thing. And so I'm really grateful to Chandos and Avenue Living and Mitrex for giving me the opportunity, and looking forward to the next one.
Thank you, Michael. So we're gonna transition to the office. We're gonna answer the Q&As, and we're gonna go to the other elevation of the building as well, so we can show you the other elevation. And then from there, we're gonna talk about the engineering process, the ROIs on buildings that are deep retrofit or typical buildings that we have, as well as a scalability, that why these type of products are scalable, why can we achieve higher ROI, where is that 7% extra rental income coming from once we are implementing BIPV, and we have the government incentives and many other corporate incentives that are coming through banking system, that they're all gonna help us achieve a higher rate of installation and integration of the BIPV into residential market, rental residential or REITs, as well as hospitals, stadiums, universities, and many buildings that are, the asset owners are holding to them for long term. As we can see on this elevation, this is fully wrapped with BIPV. The whole building, all 4 elevations are completely covered with building-integrated photovoltaic. Every section and every elevation, during different times of the day, they're producing electricity. Once again, thanks to Avenue Living and their bold vision, as well as everyone else involved, the whole team members from Chandos to engineering team, architect team, and the installation teams. Thanks again, and we're going to transition back to the office where Jill is going to answer some of the questions, and we will be wrapping up after.
Thanks, Daniel and Corey. What a beautiful day it is in Edmonton today to be unveiling Sunrise. Hi, everyone. I'm Jill Chen, Business Development Manager here at Mitrex headquarters in Toronto. Now that you've seen the project live on site, I'm going to walk you through some of the behind the scenes details, like how the Sunrise building came together, what made it possible, and the impact that it's already having. We'll wrap up with a Q&A session to hear your thoughts. So stay with us until the end and be sure to submit your questions in the comment box along the way. For those who are unfamiliar with Mitrex, we are a Toronto-based manufacturer specializing in cladding materials, including building-integrated photovoltaics, or BIPV. We're proud to be the largest BIPV manufacturer, backed by 25 years in the cladding construction space. Behind me is our advanced facility capable of producing up to 25,000 square feet of solar material just in one single day. Our team of architects, engineers, and project managers provide full support from feasibility studies to energy modeling and turnkey solutions. We take a consultative approach, tailoring each solution to the unique needs of each project. So as sustainability takes center stage, BIPV offers a smarter way to build. It is ideal for projects with large facades, especially where sustainability goals matter. Whether you're driven by environmental stewardship, ESG targets, building codes, local mandates, LEED, or other net zero initiatives. Beyond sustainability, it also offers fast installation, low maintenance, and long-term energy resilience like you saw earlier today. This makes it a really great fit for new builds as well as retrofits in sectors like high-rise residential, universities, healthcare, airports, and even parking structures. And what makes BIPV stand out? Well, it helps meet sustainability goals and it delivers ROI. So here at Mitrex, we offer a complete envelope solutions from solar cladding to solar railings and solar glass and non-solar facings as well. Our two cladding systems, our eFacade Lite and our eFacade Pro, come in a range of sizes and colors to meet different project objectives. For non-solar options, we offer our legacy products like stone, brick, porcelain, and aluminum facings. Our solar railing systems can easily replace traditional railing systems and feature similar components. And lastly, our solar glass can be used in IGUs, in window walls or curtain walls, and features semi-opaque appearance. So let's dive a little bit more into the specifics of the Sunrise project. For Sunrise, the original design included fiber cement siding with a varied color palette and a beautiful mural. The team behind the project placed a strong emphasis on environmental responsibility and deeply cared about the impact of their materials and the aesthetics. Originally, the project considered traditional solar panels, but wanted something that met their sustainability and their aesthetics goals. And that's what ultimately led them to explore alternatives, ones that aligned better with their environmental values and performance targets. And this is ultimately where BIPV came in. It completely replaced the fiber cement siding, offering a solution that maintained the colorful design, like you all saw earlier, while significantly boosting energy performance. We were able to customize the BIPV panels to integrate the mural directly into the facade, creating a dual-purpose surface that generates solar energy and showcases meaningful artwork. And it doesn't stop there. This system provides a 267 kilowatt system with an estimated payback by year 4 and significantly cuts maintenance costs. So if you're wondering what exactly are these panels and how do they work in a project like this, let's take a closer look. For Sunrise, we used our eFacade Pro system, which includes 48 standard options and the ability to create custom panels, which is exactly what we did for this project, including the mural integration. Here you can see the vibrant customized palette selected for Sunrise. And each panel is made with high-performing monocrystalline cells, durable, tempered, and laminated glass, and the option for honeycomb backing or frames. The custom colors are embedded into the laminated glass, which means it won't yellow, fade, or discolor over time. That mural is going to look as beautiful and vibrant for the next 30, 50 years. Panels can be installed using rain screen systems or integrated into unitized or prefabricated systems. And these systems are commonly used in construction today and can help simplify how BIPV can be installed, making it easier for teams to incorporate solar into the building envelope. The flexibility in the appearance and the installation means these panels can adapt to a wide range of project needs, both aesthetically and also technically. At Sunrise, we worked closely with the project team from day one. We started with a consult to understand their goals and present fitting solutions, then moved into design, prototyping, color optimization, and energy modeling. Our team developed the complete wiring plan to accommodate for the mural's intricacies. From testing to manufacturing to on-site support, we were involved in every step of the way, ensuring the process was straightforward. And the final facade proudly features the Land We Share, which is designed by Lance Cardinal, a Cree artist from the Big Stone Cree Nation. This mural is a powerful celebration of Indigenous heritage, culture, and community identity, creating a meaningful connection between the building and its surroundings. It's also just been awarded a Guinness World Record as the largest solar mural in the world. So congrats, everybody. We are extremely proud to have played a part in making this mural possible. Our system now powers close to 60% of the building's daily energy needs. It exceeds decarbonization targets, and it meets both the aesthetic and the functional goals with minimal maintenance. We made sure the design wasn't just about hitting numbers, but also about creating something that was meaningful and built to last. And this project really shows how smart design and clean energy can come together to make a real difference, both for the planet and for the community. We are proud at Mitrex to operate the world's largest BIPV facility equipped with fully automated cutting-edge technology. We're also the only BIPV manufacturer in the world with an A2 fire rating, and our products have passed tough certifications like NFPA 285, ULS 134, IC 61730, and 61215, plus Miami-Dade County hurricane testing. For those who aren't super technical like me, this basically means our products have gone through extensive testing to prove they're fire safe and built to handle hurricanes. We also back it all with a 25-year warranty on both product quality and performance for lasting reliability. And when it came to installation, our panels at Sunrise were installed with a rain screen system, a very common method in the cladding industry. This system controls air pressure and prevents water penetration while allowing the building to ventilate naturally. Suitable for new construction and retrofits, the system can be stick-built or pre-assembled, keeping installation simple and straightforward. And incorporating the system into Sunrise provided an additional insulative value of R12, which helped the project hit energy targets. We also handled ventilation cutouts and complex geometries, including corners, like you see here in this top image. A compartmentalized flashing system was used to meet local fire codes and ensure safety compliance. And there were tight site limitations, but we overcame them by using scaffolds, boom lifts, swing stages, and scissor lifts. The installation process is quite straightforward and closely follows typical cladding construction methods, making it very easy and familiar for contractors. In terms of the electrical design and the installation, our in-house engineers designed the full system. Panels were wired in series and parallel for optimal output. We use standard components, DC optimizers, inverters, a panel board, and a disconnect switch. These are typical components from a solar perspective and readily available on the market. For 40,000 square feet of BIPV, only 5 inverters were needed, which were installed into the garage of the building and meant no extra space was required to house these components. The system provides energy for everyday use, while excess power can be sent back to the grid. Real-time monitoring software can also allow continuous tracking of the system's performance. And now we're just getting to the fun stuff, the part I think everyone's been waiting for, the return on investment. Because the facade is offsetting close to 60% of the building's energy use, the project is going to pay for itself in just 4 short years. Then, starting in year 5, the savings really add up, around $80,000 annually. And to put that into perspective, it would be the equivalent of revenue from 7 additional units. This system produces about 180,000 kilowatt hours annually, which is enough to power 23 average homes. And the best part, the panels are maintenance-free for 30 years, so those savings and performance keep coming worry-free for decades. So to round all of this out, Sunrise is a perfect example of how deep energy retrofits can do more than just save energy. They can bring together sustainability, culture, and smart economics all in one. First, we exceeded the decarbonization goal, reaching close to 60%, which goes beyond the original target, setting a new benchmark for retrofitting a high-rise building. By replacing fiber cement with BIPV, Sunrise now also has durable cladding that also generates on-site energy, a dual-purpose solution that delivers a measurable return on investment. Beyond the numbers, the mural by Lance Cardinal integrated into the facade celebrates the local heritage and strengthens the building's connection to its community. Plus, Sunrise is stepping up as a sustainability leader. By choosing Mitrex BIPV, they can demonstrate how retrofits can address aging infrastructure while advancing broader environmental goals. The project shows how innovative BIPV technology can deliver long-term energy savings, cultural richness, and real environmental impact, setting a new standard for future developments. This is what the future of construction looks like: smart, sustainable, and deeply connected to place. So thank you all so much for following along today. We hope you are as excited about this project as we are. It is a great example of how innovation, sustainability, and culture comes together. Now, let's hear from you. What questions do you have? Whether it is about the technology, the installation, the design, or anything, let's get the conversation going. All right, Sean Davis, thank you. Do you have some typical details on how the panels integrate with a building's water barrier system of a building that is considering replacing the current cladding? So it would just follow the typical assembly as a traditional rain screen system.
Hi, Jill. Can you hear me?
Yeah, I can. Hi, Daniel.
Hi, Jill. Okay, so I'm going to go over some of the questions that we have, the questions that we are receiving here. One is, what is the typical payback for the system? It really depends on the type of system and the location, but our typical payback is less than 3 years. And there are projects such as the Sunrise, which could be a 6 months payback. So it really depends on the color, orientation, location of the building, how much sunlight it receives. And we can model that through the project estimations and the modeling that we have. And we can estimate the time for the payback. But just for the rule of thumb, we are looking at less than 3 years for a typical project. The second question that we have here is about the system and how does it integrate? How does the system works? What is the connection system? All the details that we have on a rain screen system is on our website. Typically, such as the Sunrise building or most of the projects we are using rain screen system, but there are applications that we use prefabricated solutions. Those are a slab to a slab high rises that we can connect them through the building. But all the detail for rain screen is available on our website. For e-facade lights, we have the BIM and the Revit files as well, and we are finalizing the other files for the BIM and Revit. But anything that you need, you can just reach out and we can share the connection details, electrical. All of our drawings come with SLD and electrical connection as well as building connection. So those are all publicly available through our website. The other question we are having here is one of the panels gets damaged. How do you replace it? Obviously, there are two ways to replace the panels. One is to remove the whole panel, including the backing and the structure, and replace it with a new panel. But there are situations that on a prefabricated solutions, we don't want to remove it because it's a wall structure. In that case, we have a system that we will shave off the glass and relaminate another BIPV to the existing wall. We have the document and the case study for both of them. It does not happen a lot. It happens a lot less than people they expect. These glasses are laminated, tempered, usually 6 to 12 millimeter thick, depends on the project, and extremely hard to damage the panels. But if it does happen, we do have solutions for different systems. How does it connect to the grid? That's a very good question. So the connection to grid is typical. Once the panels are installed, the installation is same as any other solar installation. So imagine when we are installing solar panels on a roof, they go to inverters, they go to the panel, and then they get distributed to the building. Now, they're like at night when the sun's not shining, we don't have the solar power. There is more electricity coming from the grid or the batteries. And during the day, as the building is ramping up, we start getting more power from the building itself. So the connection, there is no difference between our system and solar farms or solar roof or commercial solar. Exactly the same process. Basically, what you are having and what you're looking at here is a vertical solar farm. Next question is, what is the system warranty? Another good question. Our system warranty is 25 years from the building material. 25 years. Obviously, our modeling and our testing shows they can go way behind 50 years, but we guarantee and we warranty the material to last at least 25 years. Next question, what kind of long-term impact, financial, environment, or reputational do you foresee for the client? Well, the obvious long-term effect is the sustainability. This building is going to produce electricity for at least 3 to 4 decades. So think about it. Kids that are born today will be 40, 50-year-old. They can pass by this building, and the building is still working and still producing electricity. That's not something you typically see in a building material. Usually building materials, they age, and you have to replace them, but not Mitrex BIPV. They will last for decades to come. Next question is, how long until this goes mainstream? Well, we are doing our best. Hopefully, tomorrow, but realistically, we need to do a lot more building. This is our second live for a retrofit, 1,000 to go, as I always say. We are not gonna stop. We're gonna keep doing these projects and these buildings until it's mainstream. Next question, are these BIPV panels lightweight as compared to standard precast system? Yes, these panels are only few pounds per square foot. Anyone can lift them. They're very, very much lightweight. They're in the category, one of the lightest of lightweight panels. They do not add any strain or any weight to the structure. They're great for retrofit. That's one of the main reasons they're great for retrofit. But just like any other cladding material, they can work on retrofit or they can work on new construction, and they're extremely easy to integrate. Next question. What is the maximum power that you can generate, especially for a hospital? Can it use for a heavy use? Yes. So the panels, they produce DC power, and during the inverters and conversion to AC power, we can choose whether it's a single phase or three phase, and how we connect the powers. We can get to 600 volts. We are, tomorrow we are recording a hospital that we worked on and we supplied. We are actually going to Calgary and we will be recording the hospital. But any industrial building, any commercial building, it can go on. We have a stadium here right next to us. It can go on a stadium. We are working on airports. It can go on ports and airports. It's great for parking structures as well as the main structure for the airports. Hospitals are a great example. Labs, we are working on many labs, and this year we will be doing at least 1 or 2 other labs in Toronto and in US. You're showcasing the labs, and yeah, so the answer is yes. We can, that's part of the design, system design and SLD, and we can integrate it into basically any type of building or a structure. Thanks everyone, that's all we have. There are more questions here, but I guess that's all we can answer. One more question is about efficiency of the modules. We can design modules just to work just exactly like a solar panel, or we can reduce the efficiency by adding many colors or textures or design, and we can design, we have full control over it. So there is no limitation on the module efficiency. We can have modules that are over 20%, 24%, 22%, or it can go down to 11, 12%, but it really depends on the client need and the design we are trying to achieve. And when is a good time to, to initiate a conversation with us is always the earlier you engage, the better. We would like to be part of early conversation, early design. The later we engage, it is doable for us to do the work, but there are more obstacles and more surprises. So the earlier we are involved, the better. And I think that brings us to the, to the Q&A. I want to thank everyone, all partners, installation partners, office partners, our sales team, our project team, Hessam in the office. He's doing great with helping us getting all these projects all over the world up and running. Our production team, everyone, yeah, there are many names. I'm sure I'm going to miss someone, but everyone who is helping us making this happen. We have done several buildings, and again, this is the second live out of 1,000. We're going to keep doing these live events. We're going to keep taking people to the actual job site, showing them the actual projects. The projects are real. This is happening, and buildings are going up using this material. This is a new technology. We understand real estate and integration takes time, but it is happening. So, and at the end, I want to thank my partner, Mark, for being a partner in the journey, helping us make this happen, and being supportive of Mitrex for the past few years. And hopefully we can have, instead of 2 or 3 buildings in Edmonton, the whole city to be converted to BIPV in Edmonton, Calgary, Alberta, Canada, North America, and globally. Nothing is going to stop us. It's happening. It's time to join Mitrex. Thanks, everyone.